these are the exceptions I'm throwing, this is the functionality you can expect, and this is the features that I offer during these circumstances. And then you know that whenever you inherit that, you have to adhere to those rules. But if you're looking at abstract base classes that don't actually have an implementation, or you're looking at interfaces that don't have an implementation, they don't necessarily define what exceptions are allowed to be thrown, what preconditions you have, what postconditions, and all of that. So it becomes a little bit muddy when it comes to this. You'll have to figure out how to solve it. I'm not going to tell you because I don't really know. I'm honest, at least. Benefits? Well, I think it's pretty obvious, right? The benefits are, I've gone through a single responsibility, I've done open-close principle, I've got all of these tiny little classes, I've got a gazillion tiny classes that I'm not allowed to modify, so I keep adding new versions of them over and over and over and over again. I need to make sure that when I start adding all of these new classes and all of these new implementations, that existing systems don't break. Listgovs, if you follow the rules of Listgov, you will create classes that will actually be able to plug in and replace the existing implementations without you breaking existing applications. Interface segregation principle. So interface segregation principle is clients should not be forced to depend upon interfaces that they don't use. Yep, it's about that simple. I don't want to have classes having to get this massive interface with a whole lot of functionality when I only need a little bit of it. So we want to break down our interfaces in so small pieces that a class or somebody using that interface only gets exactly what they need. Yeah, that's a valid point, right? Who cares? If you get too much, just ignore it. The problem is that when I get too much ice cream, I tend to eat it. If you give a class too much functionality, he tends to use it, and he might not want it. You might not want him to. So break down your interfaces into smaller pieces because it will make it easier to implement that piece of functionality. Once again, you're coming back to a bit of the single responsibility stuff. If you make a really small interface, it's really easy to implement. It makes it really easy to switch out, and a person or a class can be dependent on just a little bit of functionality. So if you start looking at some interfaces, you got code? Yes. I couldn't find that many interfaces to break down. So one of the problems with building a simple project like this and showing it on stage is that you want to have a project that is small enough to demo, but big enough to not be like a hello world application. And in this case, for the interface segregation, there wasn't a whole lot I could do. But I did take my document storage, and I kept the abstract base class because I want to have the implementation like that. I can keep that if I want. But I did introduce two interfaces, input-retriever and document-persister. Basically, it means that I've now broken down the idea of getting information and storing information into two separate interfaces. And it means that, you know that document storage that I had that was breaking the implementation, the HTTP input retriever? That can now implement only input retriever. It doesn't have to throw a new exception or throw a not implemented exception because it's trying to implement things it doesn't have. By having these really small interfaces, it's really simple to implement them, and I can require them. And anyone using input retriever knows that that's what I'm getting. That's all I need. I want to be able to pull out data. And anyone using the document persister needs to persist things. If I don't need both, then I don't request both. I don't ask for both. I just take the one that I need. So in general, that's a fairly simple point in the interface segregation principle. Just break down your interfaces. Don't make them these big monolithic interfaces that, oh, I want to implement this little piece of functionality here because I want to do something, and then I have to do all of that. You can be combining your interfaces into like super interfaces. So you can take a lot of very small interfaces and put them into a bigger one if you want to. That might help, because in some cases you end up with like classes needing a whole heap of different interfaces, and if you do dependency injection and constructor injection, your constructor needs like 4, 5, 6, 8, 10 different interfaces to do its work. In some cases it can be good to create a combination, but it does have issues doing that. It kind of breaks this thing again. And also, if you have a class that requires 10, 15, 20 different interfaces, any potential that it's actually breaking the single responsibility thing? Yes. You were supposed to go, yay, yes, he's going, okay. Sorry, you're now all asleep. Benefits of this, you get really small, tiny pieces, easy to implement, easy to switch out. You can have tiny little interfaces, and you can have your class implement 10 of them if you want to. That's not a big problem. But the guy needing the functionality can ask for a little bitty piece of it. He doesn't need to have the whole thing. Just how many of you have worked with ASP.NET's membership providers? I got a little laugh down here from the Microsoft guy. How many of you love the membership provider? There's one brave soul. Okay. Yeah, exactly. Huge interface. I like the membership provider. I like the idea behind it. But the fact that if I want to switch out how I retrieve my users, it's not uncommon that I want to build a website where I want to be able to retrieve users from some custom store somewhere. I can't actually do that without implementing a gazillion other things like update user and update password and password reset and all of these little things that I don't care about. So how do you solve that? Well, you inherit from membership provider, and then you just go throw not implemented exception in 98% of the methods and implement the 2 little pieces that you need. Massive fail. I think I'm allowed to say that now. They've moved away a little bit from the membership provider, so I hope that. I'm trying to switch my MVP to ASP.NET. I might have just, yeah. Oh, no worries, thank you. Okay. So the last one, dependency inversion principle. And yes, it is dependency inversion principle, not dependency injection principle. There's a massive difference between dependency inversion and dependency injection. Okay? It's the first thing to keep in mind. So definition of this, I think I pulled it off Wikipedia. A, high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend upon details. Details should depend upon abstractions. Yeah, so everyone should depend on abstractions. We got that. Is anyone actually going to implement anything? Because yes, he's not going to be dependent on anything. He's not going to be dependent on... Yes, someone needs to implement something, as long as he doesn't depend on anything implemented. Okay. I'm not really selling this principle, am I? Basically, if my classes take dependency on some specific implementation, I lock myself in. I make it a lot harder to change things. By making sure that they don't depend on specific implementation but abstractions, I can actually just change out my implementations however I want and make all of these changes. So I've got this thing here. Just imagine this. It looks very similar to the application I've built. The app uses a persistor, and the persistor uses system.io.file to save information to disk. OK, that's cool. Not really, because it means that my application can never, ever move away from using file. Due to the fact that my app is dependent on the persistor class, I have implicitly taking a dependency on system.io.file as well. That's not good. I will never be able to reuse persistor anywhere that I want to use the other function that persistor has, unless I want to save things to disk. If I switch that out and make the app dependent on iPersistor, the implementation of iPersistor depends on iStorage, and iStorage basically has some form of implementation that stores it, in this case, to system.io.file or whatever. It means that my app can switch out the persistor. So if my persistor has some logic in there, I can switch that out for other logic. Once again, going back all the other principles backwards, it's really useful to be able to switch out things. And once again, if my persistor is dependent on iStorage, I can switch out the iStorage, so my app can still use the same persistor, but I want to be able to switch where it actually persists the information. It gives me so much more flexibility because I can just do that. I can switch the persistor for my X persistor, and I can switch my storage for Cloud Blob storage instead. All of a sudden, I've got all this flexibility of being able to move things around in my application, which I didn't have before. But as soon as I put anything, any dependency, without having an abstraction on top of it, I cannot change it. I cannot make modifications. Whenever you see anything that you might want to switch out or might want to change, put an abstraction on top of it. I've gotten to the point where I don't rely on anything, more or less. If I see that I'm going to be writing to disk or saving something, persisting something somewhere, that becomes an interface, because I want to be able to change it. I know that my boss is going to tell me that it's going to be disk right now, and it's always going to be disk. And I know that 4 months later he's going to come and tell me that we're going to be working with Azure, and it's all going to be blob storage. And if you imagine that I had followed the other solid principles more or less, but I didn't have my abstractions, changing out my storage means that I would actually have to go all the way up and switch out my class, because I'm not allowed to change things along the way, right? So all of a sudden, I have to change out the whole system. So I pulled up a couple of different dependency inversion strategies and put those into my application. There are a whole bunch of different ways of doing it. Most people, whenever you start talking about dependency inversion, people will throw out, oh, I need an IOC container. I need to pull it in inject, or I need Unity, or I need AutoFac, or something like that. And I want to configure all of this complicated stuff, and it takes me forever before I can start working on my application. You don't need that. You don't necessarily need to do IOC containers to do dependency inversion. There are other ways of doing it. So I've done 3 different versions. I've got a manual one, where I don't take dependency on anything. Once again, taking a dependency on an IOC container, it's a dependency. So you've got a dependency on something that's going to keep your abstractions. So you want to put an abstraction on top of your thing that keeps track of your abstractions. It's the obvious way of doing it, right? Until you have a dependency on that abstraction and one abstraction, and then it becomes really complicated. So the manual way of doing it, I've changed my format converter to take 2 classes, or an interface and a base class, as parameter to my constructor instead. That's dependency inversion. This class, my format converter, is now saying, I need these things, but I am not going to be creating them for you. I'm not going to be taking dependency on a specific implementation. I'm going to let you tell me what I need to use. That's one thing. I've also introduced a couple of factories. I've created an input retriever.for file name, a static method that called for file name. And now people are going to yell at me and say, static stuff is not good. Static stuff cannot be tested. Static stuff is crap. Static stuff doesn't have to be crap. This is a static class, absolutely. But have I taken any dependency on anything specific? No. Have I made it so that it's not testable? No. Because for file name actually returns, you can't see that, can you? But it says I input retriever. So the input retriever static factory class just gives me back an I input retriever. So I haven't actually taken any dependency on any specific implementation. All I've done is I have created dependency inversion using an abstract factory instead of injecting it using an IOC container or something similar. And same thing down here for document persistor. It's a static method on a static class, and it returns an I document persistor. Even though I'm using static stuff in here, I have no dependency on any specific implementation. So configuring and running this requires a little bit of work. First of all, I create a document serializer, in this case the camel case JSON serializer.